So before start the actual project explanation, I request you please subscribe my channel. So you can see on the screen up till now I have uploaded more than 66 video on Raspberry Pi. The Raspberry Pi with IoT, that is all this video. Then also IoT with Arduino, all this video are 26. And recently we started the new series on the PIC microcontroller. Before that I also cover the project on the Python web application. So if you want to learn Python, IoT, Raspberry Pi, Arduino, PIC from the scratch and from freely, then please subscribe my channel, please support me. And the most important part is whatever the code I have explained, whatever the project I have created on this YouTube channel, all these projects are freely available. You no need to pay anything for this project. So just if only point is you should watch complete video and you should follow my process. So if you want to learn something from the scratch and freely, then support me and please subscribe my channel and please click on like button. Hello friend, in today's session we will learn how we can interface the LDR sensor with PIC microcontroller. So before start the next part, I would like to tell you what will be the flow of this project. So you can see on the screen we have the PIC microcontroller, then LCD, then LDR sensor and bulb with relay. So basically what happened, when I move this torch in front of this LDR sensor near to that LDR sensor, then light will automatically turn off. Why light will automatically turn off? Because this indicate that when the torch is near to this LDR sensor, you can see this indicate that there are sufficient light inside the room, so no need to turn on the bulb. And when I take a torch away from this LDR sensor, then it indicate that there are no sufficient light inside room, then there is a darkness inside room, then please turn on the light. So to turn on the light and to turn off the light, it is completely based on this LDR sensor value. Also you will see the message on this LCD. So what we will cover in this video, so I will cover the importance of each and every line from the code so that you will get idea about this project. Also I will cover how to connect all this hardware with the PIC microcontroller. So I request you please watch this complete video so that you will get idea about each and everything about this project. Now first we will see the practical demonstration of this project so that you will get the final output idea. Now I will start the project. So once I start the project, you can see on the LCD you will find the project name display here. Then bulb on. So after bulb on message, you can see LED turn on. Why LED turn on? Because there are no sufficient light inside the room. Torch is away from this LDR sensor, and that means there are no sufficient light inside room and LED bulb is turn on. So once I move this torch in front of this LDR sensor near to this LDR sensor, then LED will turn off. So how to move this torch? There are two arrow plus you can see there are two arrow, this arrow, this arrow. Once you press this arrow, then LDR sensor move near to this this torch move near to this LDR sensor. Once I press the down arrow, then torch move away from this LDR sensor. So what I will do now, you can see firstly the bulb is on. Now I will move this torch near to this LDR sensor. So you can see after half distance, you can see most of half distance I cover, the bulb off, and here you can see LED is turn off. So once I again move torch away from this LDR sensor, there you can see bulb on and LED on. So depending on the position of this torch, the bulb getting on and bulb getting off. So this is the complete idea behind this project. I hope you understand the practical demonstration. Now we will cover the hardware connection and then we will cover the programming part of this project. Now we will cover the hardware part. So before start the hardware part, I request you please watch my this video LCD connection with PIC microcontroller, because in that video I have detail explain how to connect LCD with PIC microcontroller, and the same connection we will use in the LDR project. So I will not again explain the same connection in this video because that will take too much time. So if you really want to see, if you really want to learn how to connect LCD with the PIC microcontroller, then please watch this video. This video link given in the description. Now once you have this connection, now directly we move toward the LDR connection. So if you want LDR sensor here, then you can go to the component mode, then click on P and type here LDR. So once you type LDR, select this torch LDR, click on OK and place that LDR sensor here. And after that, this point of LDR sensor should be connected to power. So just go to terminal mode, click on power and place that power here. Then after that, connect that power to power. Then this pin should be connected to register. So just go to component mode, click on P and type here register. So once you type register, you can select this register or generic register, click on OK and place that register here. Then right click on this register, rotate anti-clockwise and connect that register one point to the LDR sensor this point. Then after that second pin of register should be connected to ground. So just go to terminal mode and click on ground and place that ground pin here. Then connect that ground pin to ground. Then this point should be connected to PIC microcontroller. In between point between LDR. So point between LDR and register should be connected to PIC microcontroller. So just go to the terminal mode, click on default, place one default pin here. Then right click on the default pin, rotate 180 degree, connect that default pin like this. Like this you can connect. Double click on the default pin, you can give name here LDR and click on OK. Then after that you have to go to the PIC microcontroller analog A0, then go to terminal mode, click on one default pin, place one default pin here, connect the default pin here. Double click on the default pin, give a name here LDR, click on OK. So in this way we complete the LDR connection with the PIC. Now once you have the LDR with the PIC, the next party we have to connect the relay. So just go to component mode, click on P and type here relay. So once you type relay, select this relay, animated relay, click on OK and place that relay here. Double click on this relay and operating voltage should be changed to the 5 volt. Click on OK. Then here you will require one LED. So just go to component mode, click on P and type here red LED. So once you type red LED, select this red LED, click on OK and place that LED here. Then after that one pin of LED should be connected to this pin. This pin of relay should be connected to VCC. So go to terminal mode, click on power and place that power here and connect that power to power. Negative pin of LED should be connected to ground. So go to terminal mode, click on ground and place that ground here. Connect that ground to ground. Then this pin of relay should be connected to transistor. So go to component mode, click on P and type here NPN. So once you type NPN, select this NPN transistor, click on OK and place the transistor here. Connect this transistor to transistor, connect this transistor this part to ground. So we go to terminal mode, click on ground and place that ground here. Connect that ground to ground like this. Then this pin should be connected to VCC. So terminal mode, click on power and connect that power to power, this one. And this pin should be connected to PIC microcontroller. So just go to terminal mode, click on default, place the default pin here, connect the default pin here, double click on the default pin, give name here relay, click on OK. Now this default pin should be connected to PIC. So here you will find this RE2. In this RE2 you require one default pin, select the default pin, right click, rotate 180 degree, connect this pin to here, double click here, give a name here relay, then click on OK. So in this way we complete the hardware part of this project. So just one short update here, the transistor whatever we selected, that we have to modify. Just go to component mode, click on P and type here 2N2369. So this transistor you should select, click on OK and place the transistor here and connect this point of relay should be here, same connection, this point here and then this point should be ground. So like this same circuit. Now we have to verify our circuit. So how to verify the circuit? We require MPLAB IDE software. So this software you require. So how to install this software? I already told my previous video, this video, LED Blink project by the PIC microcontroller. So in that video I have clearly explained how to install this software in your laptop. So if you don't have the software, please watch that video. That video link also given in the description. So once you have that software, next party you require this folder, LDR with PIC. So this folder link also I will provide in the description. There is a Google Drive link. From the Google Drive link you can download this folder. So once you download this folder, that is in zip file, you have to unzip that folder and after that you will find all this file. Then double click on this file. So once you double click on this file, ready-made program you will find. Double click on this file, then you will find this file automatically open. Then just click on this build all button. So once you click on build all button, you will find this hex file path. So copy this hex file path go to your project, double click on this PIC microcontroller, click on this folder and paste that path here. So once you paste that path here, then you can see click on open button and click on OK. Then after that just click on this run button to verify your circuit is working or not. So you can see circuit is working perfectly, there is no issue. So in this way we complete the hardware connection part. Now we will see the programming part of this project. Now we will see the importance of each and every line from the code. So first line is include PIC18f. So whatever the controller we are using, that that header file we have included here. Then some basic library file, some basic setting of PIC. Then next is some function that we will use later. I will tell you this importance of this function later. So this is just function declaration here. Then after that L port. So this L port, RS, enable. What is the use of this? That is already explained in my this video. LCD video. So please watch that video. I will not repeat that part here. So next is RE2. So this is the extra one that is used for the LDR circuit basically program. So relay is basically, you can see on the circuit diagram, the relay we connected to the this relay, that is bulb, we connected to the RE2 pin. So you can see RE2 pin. So that RE2 pin I have defined here with the relay. Then after that some string, smart system bulb on bulb off. So that those are the string I define here. We will use that string later. Then first is some variable, then some string, then LCD initialization. So this is very important part. So once you go to LCD initialization function, here you will find some basic setting of the PIC microcontroller. So tris D is nothing but one register which is used to consider as a port as input or output. So you can see on the PIC we have many port, D port, we have C port, we have A port, we have B port, E port. So whatever the port we are using for the LCD, that port we define as a output port, because I already explained why that output port in my this video. So all this port for the LCD that is defined as output. So tris register is used to define any port as the input or output. So D port and E port are defined as output port. Then port D, initially we are sending 0 value on this port D. Initially we are sending 0 value on port E. Then ADCON register, that is 01. So what is use of ADCON register? So for that you should open the datasheet. So datasheet also I will provide in the description. So just search here ADCON. So once you search the ADCON 0, just search ADCON 0, then automatically you will find there are 3 register of the, there are basically 5 register for this ADC, ADH, ADSL, L, then ADCON 0, 1, 2, 3. So first we will see the ADCON. So as per our program I have given the ADCON as a 01. So why 01? If you see the ADCON register, so 01 means this AD. If you convert that 01 into the binary form, so if you convert the 01 into binary form, you will find 000001. So if you map this value with the ADCON 0 register here, then you will find 00000001. So AD on is 1. So AD on is 1, nothing but the start the ADC. To enable the A to D converter, we have to give the 1 value on the bit 0. So that's why we have given here ADCON 0 is 1. Now the next is ADCON 1 is equal to 0. 0 is nothing but the 14. So 14 if you map with the this data sheet. So 14 if you map with the data sheet, you will find here that value 110. So all the pin analog pin work as a digital, only analog 0 pin work as a analog. That's why we map ADCON 1 as a 0E. Then after that next line is ADCON 1. ADCON 1 is 18. So 80. So 80 nothing but the 1 and all 0. So here you can see 1 and all 0. So ADCON 2 1. So right shifted justify we use. So that is the basic setting we use for the A to D conversion. Then once you have the all the ADC conversion, next is LCD command. So all these lines I already explained in my previous video. This video, please watch that video, you will get idea about this line. Again this function also I have explained, this function also I have explained, this one also explained, this one also explained. So please watch that video, you will get idea about basic LCD connection and their functionality. Now I move toward the main part of this project. So here you can see once we have the LCD in it, then we should print the string 1. So string 1 is nothing but the smart bulb on the line first row of the LCD. Then on the second row we have to use system. So smart bulb system will be print by using this line. Then after that while one. So inside the while one there is, you can see there is a read ADC function. So inside this read ADC function you can see there are many lines. So first line here you can see there are some variable. Then we will see importance of each variable later. So first very important part is whenever we want to start the ADC, we should start this go go variable. So a decon 0, from the decon 0 there is a go register that should be one value. So once you give one value to here, the ADC start converging their value coming from the LDR sensor, and once that conversion is completed, then this AD done value should be 0. Then as soon as this value should be 0, it will jump to this line and hexadecimal number will get all the ADC value. So whatever the analog to digital converter value, that will be stored into these three line. You can see these three line, and those are the hexadecimal. So at this line you will get at the end hexadecimal value of your analog value, analog and digital value. So whatever value coming from the LDR sensor, that is stored into this hexadecimal number array, and that array is nothing but some value, and that value should be converted into hexadecimal by using this three line. So how to convert? Let's say for example you have 0 value. So as per our ASCII table, so you can see as per our ASCII table, the 0 value of our decimal, you can see if there is a 40 you can see 48, if there is a 48 decimal value from the analog, if you want to convert into the 0 value, then we should add the plus 30 hexadecimal value. So you can see that's why whatever the value coming from the ADC, I adding with the 30, and that will be changed to the hexadecimal. So from 0 to 9, whatever value it is coming, I will add with the 30. So it will convert into hexadecimal from 0 to 9. So after 0 to 9, in the hexadecimal we have ABCD. So if you want to convert that into ABCD, you can see as per ASCII table, there is a 65 we have to add, but already we have till 10 value. So 65 minus 10 is equal to 55. So that's why we added here 37. So 37 is nothing but the 55 in the decimal. So whatever value coming, we added 55 here, and that will convert into hexadecimal. So ultimately we will get the hexadecimal value from our ADC. So once we have the hexadecimal value on our ADC, from our ADC, we have to convert that hexadecimal value into the decimal. So how to convert hexadecimal to decimal? By using this logic. So again this logic, whatever I given, the logic is very simple. I am rotating my array. So inside array we will get the hexadecimal value. So that array again divided into 0 to 9, A to F and A to F, capital A to F and small a to F. So let's say if the hexadecimal value is 0, and if I want to convert that into decimal form, so what I will do? I will do minus 48 here. So why minus 48? You can see here on the ASCII table, 0 value is nothing but the, as per decimal, is a 48. So whatever hexadecimal 0 value is coming, that should be converted into decimal by minusing the 48. So that's why minusing 48 here. Then A to F, then same logic for the capital A to F. So that is the logic behind the how to convert hexadecimal to decimal. So ultimately we will get the decimal value here, and once we get the decimal value, we have to print that value on the LCD. So this decimal value is nothing from the this decimal value is nothing but the analog value from the LDR sensor. From this read ADC, you can see from the read ADC we will get the decimal value, and that decimal value store into ADC value variable. And if that ADC value variable is less than 100, that means there is a no light. So if the less than 100, then we have to print on the LCD like a bulb on. So string 3, we are printing string 3. So here you can see bulb on is here. So we are printing the string here. Then after that we are giving the one signal on the relay. So that means our bulb will turn on. If the ADC value is greater than 100, then we have to print the bulb off, and relay should be 0 because we have to turn off the relay. So this is the simple logic behind this code. I hope you understand the complete code. Now we will see the how to run you how you can run my ready-made simulation. First of all, if you want to use my ready-made simulation, then you should have the Proteus 8.9 software in your laptop. So once you have the Proteus 8.9 software, Then in the Google Traveling you will find this LDR Proteus project. You can close this project, again go to the Proteus 8.9 software, right click here, run as administrator, click on this button, then go to the open project, then go to the downloaded folder link, PIC, LDR with PIC, then select this LDR with PIC, click on open, then ready-made project automatically open. Sorry, not this project, again I will open, open project, then downloaded folder, YouTube PIC, LDR with PIC, then LDR with PIC, click on open, then automatically you will find the ready-made simulation. Then if you want to run this project, just load the X file. So how to load X file? I already told you, just compile this project and you will find the X file. Then copy this file path from the here, go to the project, double click on this PIC, click on folder, open, click on OK and click on run button. And in this way we complete our LDR with PIC project video. So I hope you understand the complete project, hardware connection and programming part. If you have any doubt you can contact me, and if you like my content please click on like button, please subscribe my channel, please support me. Thanks for watching this video.